Very good morning to everyone. Today we are going to explore a trending topic called software defined vehicle. The software defined vehicle going to be the future of mobility in within a 10 years or 15 years. We won't have the network structure or vehicle network or the way in which we drive the vehicle won't be there. So we are moving towards a completely connected vehicle which has a foundational hardware, and then the behavior of it can be changed using the software. That is going to be the software defined vehicle. So we are going to explore what it is, how it works, what are the challenges we have, all those details in this session. Okay, now. So uh, in short, what is software defined vehicle? Here, software is a main source of features and functionality. What is mean by that? So the software plays major role of how a vehicle should behave, what sort of software it should have, how it should react to event. Everything is controlled by the software. You can ask me a question. Is that not the case before? So the traditional architecture or traditional vehicle architecture doesn't have such thing. Yes, we had. Yes, we had. Even before the software played the major role in controlling the behavior of the vehicle, the problem with that one is it is coupled. Hardware and software are coupled together. Once you design the system in such a way, once you have completed the design, once it has gone to production, then it is very hard to change the vehicle behavior or hard to change the software, right? Or sometimes it is even impossible, right? That is what the traditional the vehicle architecture is. But using this software defined vehicles, we have a foundational hardware in the vehicle. For that, which these hardwares are controlled by a centralized software which has a connectivity with an external world. It can connect to the cloud, it can bring the new software to the system, it can export the details about the vehicle like engine and then driving speed, those sort of things. The trip value, those things can be exported to a remote system that can be used to analyze the vehicle behavior or something like that. That is how that is how software industry or automotive software industry has been developed, right? So in software defined vehicle, what used to have what we used to have in software defined vehicle. In software defined vehicle, we used to have our foundational hardware, like we have the sensor, vehicle speed sensor, engine speed sensor, fuel level sensor, ambient temperature sensor, and then ambient light sensor. So these sensors setup, what we used to have in our traditional vehicle, those will be there. Then what else? The computation platforms like the sensors based on the wheel count, how the vehicle speed has been computed, and similar way how the engine temperature, engine coolant temperature is computed, and engine RPM is computed, and then how the fuel level is computed based on the resistance value. Those blocks will be there. So from there, so we get these informations, the digitized informations are going to a centralized brain that we will talk about later. This computational platform, which is used along with sensor, is not part of that particular centralized software. Then we used to have actuators to apply the brake to do different things, right? The actuator, the mechanical stuff which is controlled by electronic circuitry. These actuators are also be there in this software defined vehicle. Along with that, these vehicles are featured with a connectivity. They can interact with the cloud and can get files, can export the data from the vehicle. This, in order to establish the connectivity, there should be the necessary platform or microcontroller or an architecture to be used in this vehicle. If there is no connectivity, the software-defined vehicle is not possible. So the connectivity is a very key thing in software-defined vehicle. Then we used to have our powertrain module, that is, which is something like engine control module. That is a key thing in every automotive vehicle, right? In a traditional vehicle, that is a very key thing. These are the totally we have discussed about five. These foundational hardware used to be there in software-defined vehicle or any vehicle that we have in the market today. Then these software, the value, those are read from the sensor, or those are taken from the different sensor, were communicated to a centralized software platform. Centralized software platform, that software platform should have certain things. So these are the key for software defined vehicle again, right? These central software platform should have an OS. What is OS? It is an RTOS. It can be your Linux, Android Automotive, or a QNX. There should be an operating system, because these particular vehicle require a lot of drivers and lot of stuff those to work with, because they are connecting with an external world. In order to cope up with an external world environment, these vehicles should have an operating system in place. Then we talk about the middleware. These middlewares are something called a hypervisor. These middlewares helps the vehicle to execute different operating system without affecting each other. That is like these middlewares perform those things. They are called as an hypervisor. That is common in software defined vehicle, because different apps will support different OS. So in that case, we need to have different OS to interact with them. That is what the job of middleware. Then we have a data management. These centralized platform, as it is gathers the history of data, those are happening in the vehicle. There needs to be a place or a location there it can store a huge amount of data, like a database. Then it can export or broadcast those things to the cloud for analysis, right? OEM can get those data and use. For that, there should be a proper arrangement made for data management in these vehicles. Then the security. When you are connecting with the internet, or when you are connecting with the external world, we have a problem of security threats, right? Somebody can hack our vehicle, somebody can compromise our vehicle network, so that he can inject something malicious things to our network. To avoid that, there should be a proper security in a place. That's why that automotive cyber security come into the place. Finally, for an autonomous driving or advanced driver assistance system, for these sort of things, we need AI in place. So artificial intelligence and the machine learning, for to support there should be a software or hardware should be available in that system. These are the key things needs to be there in the centralized central software platform that act like a brain for software defined vehicle. Then this particular software defined vehicle should also support over the air update, meaning without any without vehicle visiting the service center, the vehicle can be in the garage of end user. It can get updates from the OEM, right, via telematic connectivity. So it can connect with the cloud, OEM cloud. From there, it can get the updates and can renew its software. When there is a new feature, it can get it, and then automatically it can be installed. So the over the air connectivity or over the air support, that means OTA, over the air installation of software and bootables, should be possible uh, in this particular vehicle. That is a key things in software defined vehicle. in this software-defined vehicle, and then when you want to enhance an existing behavior, let's say your particular indication light is glowing in a certain color and it doesn't chime. Now you want to include a chiming with the blinking, so that you can implement that in your OEM bench, then can be uploaded to the cloud. From cloud, it can be distributed to the vehicle that is sitting in the customer garage. That is possible. That is possible in software-defined vehicle. Then you have a bug. Let's say in traditional vehicle, if there is a bug in the system, usually the OEM will call the vehicle to the service center. There they used to flash. But in case of software-defined vehicle, the bug fixes can be done at the OEM bench, then it can be distributed. Then they can upload that to the cloud. From cloud, automatically via over the air, vehicle can receive the updated version and can renew the software. Right. Then the security updates. You have a security algorithm in place at present in the vehicle. You want to enhance it. You introduced a new way of new security methods. In that kinds, again, these over the air will help you to get the security update and can be installed. These new technology, new way of new vehicle architecture also build a new business model, so that people who don't even have the knowledge about vehicle hardware or vehicle network structure, they can write app for your vehicle. That is possible. So those are the different evaluations that happen in software-defined vehicle. Right. So because of all these things, the software-defined vehicle can support advanced driver assistant, autonomous driving, very colorful infotainment features, navigations, personalization, personalized vehicle, as we used to personalize our Windows OS, we can personalize the vehicle settings, and then you can optimize the performance, right? So those are the key differentiations that we can make in a software-defined vehicle.